Hey guys, what's happening? Will Robinson here from Robinson's Auto, toolsandtime.com. Welcome back. Today's not going to be an automotive related video. It's going to be more residential. We're going to see if we could take what we learned from the schematics on automotive and see how they could apply to residential electric as well. The first thing I want to do is verify the symptoms. So evidently this dryer is working. It's spinning, however it's just not heating up. So I'm just going to verify that. Just selecting some kind of heating point in the timer knob. As you see, everything, we know we have power. So we know it's not a trip breaker or something simple along that line. Okay. I had this thing running for about 30 seconds, so there should be some kind of heat in here. There's nothing. Another thing I want to show you, if you need to find your model number on this Maytag, it's located right inside the door. Well, for me to continue my troubleshooting, I gotta pull it out from this hole, so I'm just gonna take and slide the dryer out. Not sure how beneficial this will be, but when I have something in a tight spot like that, instead of trying to wrestle it from the back and sliding it out, just simply open the door, grab it from inside, and pull up and slide out like that. Okay, now usually right behind this back cover or somewhere they supply a wire diagram, so we're going to take and open that cover, but before doing that you want to make sure you disconnect it from the power source. In addition to turning off the breaker, I recommend pulling the plug. You know, that's the right there, you know it's disconnected from the power source. Pretty much for this whole job you're going to need a 1/4 inch nut driver or a 1/4 inch socket. I'll be using a 1/4 inch nut driver and a Phillips head screwdriver. We're going to take and remove these 3 retaining screws from the top, and then right in the back we got the 1/4 inch retaining screws as well, and there's 3 of them. Let's take and remove them. As you can see, this back cover comes off, and there's your wire diagram. Okay, before we go too much further, we gotta go over some of this wire diagram to see what we're going to troubleshoot first. And if you look here, you got this diagram on the left, and you got another diagram on the right. They're pretty much the same diagrams. You can troubleshoot from one to the other. I use them both, so, and I'll demonstrate that as we go. But if you look here, you got L1. Okay, you follow L1 over, you got a neutral, and then you have L2. So from L1 to L2 you have your 220 or 240. Okay, because L1 is your 120 power source. That's one power source. L2 is another 120 power source. So from L1 to L2 you'll have 240. From L1 to neutral, they're sharing a common neutral, you're going to have 120, and vice versa. Okay, and if you come over here, they demonstrate this and they actually put it out there for you. So from L1 to L2, 240, L1 to neutral, 120. If I'm looking at this schematic right, I'm going to show you how to test this switch and whatnot and the momentary push buttons. However, most of your control voltage is 110 from L1 to neutral. If we follow down L2, goes through your motor switch. That's pretty much what controls your heating element. Okay, so it has a 240 volt heating element. Correct, because it's coming from L1 to L2. So everything will still work as far as the drum spinning if I lost L2. I just want to have a heating circuit. So I want to just make sure we don't have a faulty breaker and check all my power source. So we're going to have to do this test live. Okay, if you come down here on the terminal block, they don't have L1 and L2 designated on the block. However, L1 should be black, L2 should be red. You can look at the diagram and verify that. L1 black, L2 red. Okay. Okay, I got my DVOM. We're set up to AC volts. Got the cover removed. We are plugged into the power source, so you want to use extreme caution. This is 240 volts. Okay, if you remember earlier when I mentioned the black lead is L1, the red lead is L2, the white lead in the middle is your neutral, and you can see it has a ground lug going to ground to the chassis. So if we go from L1 to neutral, you should be 120. L2 to neutral, you should be 120. L1 to L2, you should be 240. So let's verify. Okay, neutral. L1. Okay, you got about 124. Neutral to L2. You got about 124. L2 to L1. You got about 248. So we know our power source is good. We're going to take and unplug. Okay, now if any of those tests fail, then you know the problem is not in the dryer. Well, there still could be a problem in the dryer. However, you know your power source ain't good, so you got to troubleshoot your house circuit. Most likely a breaker or a faulty breaker. Okay, next, to be honest, what I would normally do in this scenario, I would go straight for the heating element and check that, and then I would check all the thermostats. We know that this safety fuse, this thermal fuse, it's not reusable, so once that opens, it's shot. It's got to be replaced. We know this is good, and how I verified that is simply, if you look at this wire diagram from L1, you got your cylinder light, so it comes over, comes to a door switch. When you open your door, the switch closes, and this thermal fuse, as long as that fuse is good, will light up your cylinder light. And when we first came in, I opened the door and that light lit up. And I'll demonstrate it real quick for you. And that's a quick way to test this thermal fuse without getting down to it. You can simply let the machine test it for you, and that'll test this switch. It won't test it 100%, but it will test that thermal fuse. And okay, just for a quick demonstration, I plugged it back into the power source, so you're going to want to keep that in mind. And as you can see, we just tested that thermal fuse. Unplug it from the power source. Since I kind of like the direction this is going, I would normally at this point, knowing that my dryer starts, I would simply jump right down to the heating element and check all this. However, I just want to give you a quick demonstration on how to troubleshoot other symptoms in case you run into them. Okay, so now we know that our thermal fuse is good. The circuit comes down here with the door closed, comes down, goes through your motor, over to a momentary push button. This is your timer selector knob. This is this knob right here. Okay, this momentary push button, when you push it, it'll allow M, okay, this is on the back side of that knob, it'll allow M to go up and go to S and start that motor. That's if there was power. Okay, but we know there's not, because if we look at L1, you follow that down right here, whenever you have a solid dot, that's a connection. Whenever you have a hump that goes over and it's not a solid dot, that's just simply not attached to that wire. That's just another conductor running somewhere else. So if we come down, we see L1's not going anywhere. So this is the timer. So this knob needs to be turned to some kind of setting. This contact will close, and that'll put L1, or that put L1 L to M. Give that power to your momentary button. You push it down, it goes through. to your purple wire, which is S, and starts that motor. Okay, so let me show you how to check that switch. We're going to do a continuity check just to check to see if this momentary push button works, in case you have a dryer that doesn't start when you push that button. I'll show you how to get back there and test that. So we want to find M and S on the back side of this timer. That's that part of the button. But even with a dryer that's in working condition, if this is in the opposition and you push this, it's not going to do nothing. And that's just an example of why when you push this momentary button, M has nothing hooked up to L1, so it's not doing nothing. But now if you take and you turn this into a time, we're in heat up mode, we just closed L1, which is L, down into M, so now we're putting power through and starting that motor. So one thing at a time, let's check that push button. M and S. So we come down here. This here is M. And this one here is S. Okay, M and S. Now I'm going to push the button. As you can hear the audible signal, that means I believe on this meter anything under 120 ohms will sound that audible signal. So we know we have good continuity, a continuous loop when we push that switch. Normally open, now it's closed. If that was open, you'd have to replace your timer selector switch. Okay, so now if we go a little bit further, we now know our momentary button is good. The contacts in that button are closing, and we're getting our audible signal from M to S. Okay, so now in order to get this dryer to start, say if you're pushing it and your dryer still isn't starting, which that isn't the symptom with this one, but I'm just giving you guys a demonstration. When we turn this timer knob into a heat up mode, that should close this contact. Okay, L and M. Okay, let me give you a shot of this circuit on this side. Okay, it's very similar. Sometimes this is easier to follow, and I use them both in my troubleshooting. But as you can see, your L1 neutral, L2. So from L1 to neutral, you got your thermal fuse. I like to call this the control side of the circuit. This is the 110 side of the circuit. We tested our thermal fuse because the door switch was closed and this cylinder light illuminated. Now we're down to this side of the circuit. We actually skipped the timer portion, so we're going to set our timer knob up into a heating selection so those contacts close. And then when you push your start button, these momentary, see how it says momentary, that momentary contact will close. It'll start your motor. As long as your door switch is closed, it'll start spinning and around. So we know this momentary push button is good. Let's check our timer contacts, L and M. So we're going to put it to the opposition. L and M should be open right now, so let's check that. Okay, we know M is up top. Now we got to find L, which is right there. So that's that wire. And another way you could tell is on the schematic. It says purple. So if you find a purple wire, that'll help a little bit as well. Let's find a purple wire, which we already found because they were nice enough to show it for us. Okay, so we know this is our M, this is our L. Still set up the continuity, as you can hear from the audible signal. So M, L is open. I'm going to take and turn the timer knob. As you can hear, it just closed. So we know the timer part of this switch contacts are good. If that was open when the timer was selected, then you'd have to replace your selector timer. Okay, now some of you may be asking, if you're paying real close attention, this is just a momentary button. So when you release this button and momentary switch, these contacts open. How is that drum going to stay spinning? Okay, with the timer selected, we now have L and M completed, closed. So we have power flowing to number 7. Okay, so this timer is selected, we push our start button, it releases automatically, but as soon as we push our start button, it starts spinning this motor, because remember, our thermal fuse is good, our door is closed. So this motor starts spinning. There's a centrifugal switch contacts in this motor that will close. So even though you release your button, as long as that motor's spinning, these contacts will close and it will get its power from L and M. You get it? So now if the timer runs out, this opens, it no longer has power to run the motor, it stops spinning. So I think that's enough demonstration for this portion. Even though we knew this was working, I thought it'd be a valuable thing to share with you guys. So I'm going to spend more time now on a heating circuit. So what I did, I located the heating element. As you can see, heating element 4,750 watt. Okay, so we have a motor switch. So coming down from L2, so as long as the motor's running, this switch will close, and because this is going to be a 240 volt heating element, so the motor has to be running in order for L2 to close. But let's go from the left to right. So if we come down from the top, L1, we know this part of the circuit's good. We come down here, okay, to L and H. This is part of the timer as well. So L and H has to close for L1 to continue to H, which is a red conductor, and over to our heat selector switch. Okay, depending on where this heater selector switch is selected to, we'll say C. It'll come across, come down, go through the thermostat, come around this red conductor, come up to another thermostat, which is a safety high limit thermostat, to our heating element. As long as the motor's running, heating element will heat. Okay, so I want to make sure L1 is getting there, so we're going to set our timer. We'll check it open and we'll check it closed, but we want to make sure L and H is closing to make it to our heat selector switch. Okay, from earlier we noticed purple conductor is L, come right below it, that red conductor is H. We want to check from L to H. It's open. I'm going to turn the selector knob to the timer. It's just closed, so we know them contacts are good. Now if that was open with the timer selected to a heat up cycle, you would know your problem is in this timer selector. We come over, go through this red conductor to our heater selector switch. So let's locate the back side of the heater selector switch, see what mode we're in. What I want to show you is over here. I just looked. If you look here, this is our temperature selector knob, and we're in a regular. So I would consider that from air flush, delicate, medium. Regular is considered the high. So right now we are set on the high heat. Okay, so we go from L to H, which we just checked, and we're good. Now the heat and switch, we got to go on the back side of that and find that red conductor, which is L1, to C, which is a yellow conductor. And we got to make sure our heat selector switch set on the high heat mode is closed. Okay, there's a knob. Come back here. Red wire, it's L1. Yellow wire is C. I'm not sure if you can see that back there, but we just want to make sure that circuit is closed. L1 to C. So we know from L1 to C on high heat we should be getting power flowing. L1 to C, Goes down this yellow conductor. Now there's another thermostat. Maybe we'll check that next. But let me show you what that looks like on this schematic. So remember, we're on a high heat selector. Heat switch we just checked, L1 to C, goes down this yellow conductor, goes through the thermostat, then it goes through a safety thermostat, and then to the heating element. And as long as the motor's running, got another centrifugal switch for L2. So as long as that motor's running, it'll complete that circuit. So the next thing I would want to check would be this thermal switch, which is your thermostat. Okay, for the next part of this test, I had to take and open up the lid. I just set up that light there to give us a little more for a demonstration. However, you simply just pull up, get your fingers underneath the front lip, and it just pulls up by these clips. There's no retaining screws for that part on this model. And the next step we're going to do is we're going to get the schematic over here. We know we were good through this heat selector switch. We want to test this thermostat. Now what I would usually do, because I know on this dryer, this thermostat, I got to take the front of the dryer off to get to it. It's down in the duct. So what I'd have to do is take the front of the dryer off. Now if I really wanted to, I could take and follow this all the way up to this other safety thermostat, which is located near the heating element. So if we come back here to the heating element, we know this is our other safety thermostat. Okay, our high limit thermostat, they would call that. What I could do is go from C on the back side of that selector knob to our safety thermostat, and if it's good, if we have good continuity from point A to point B, we know this thermostat's good. But for demonstration purposes, I'm going to show you where that's located, because I want to clean the duct, make sure everything's clean on this dryer. Okay, in order to pull the front off of this dryer, you got two retaining screws. You got one here, you got one here. Okay, once you remove the two retaining screws, it just simply picks up off of and two lower clips that go into them notches. So now that we have that front one removed, we're going to locate the thermostat. Let's come back over here to the high heat, because I find it easier to follow at this point over here. So for this thermostat, we want to find the C, which is a yellow conductor, and red. So yellow and red. And we'll do a continuity check on that. So I have my DVOM set up for continuity. And once again, we're going to be looking for the yellow and red conductor on that thermostat. So if you come down here on the front of the dryer, you see how you have your duct work. Right here's your thermostat, and we want that yellow and red. This has a small wattage heater in it, but we're not worried about that at this point. We're just going to check continuity on that yellow and red. Okay, so let's see if this thermostat's good. So whatever temperature thermostat that is, when it's under that temperature, it should be closed, continuous. If it's above that temperature, it will open. So right now we know this dryer is cold, so it should be closed. So yellow, and red. As you can hear by the audible signal, we do have continuity. It's a continuous flow, so that contact is closed, so it's below its set point, and this thermostat is working at this point, so we could go to the next step. So it just came through. We just checked and verified our thermostat is working. So we come up and over. This red conductor goes to safety thermostat. That's the one located up near the heating element. That's your high limit thermostat. So we're going to go up, locate that safety thermostat, and perform a continuity check on that one to verify that's okay. There's two red conductors. I just located it. It's right here. So we're going to perform a continuity check on that one. Okay, another tip when you're performing continuity checks, if you want to be 100% certain disconnect one side of the circuit that you're working on. Say we're going to be testing this high limit thermostat. I'm going to disconnect one side of it, remove the conductor from one side. That way I'm sure I'm not getting feedback from any place else. Because any kind of resistance under 120 ohms or so is going to give us that audible signal. So with this circuit disconnected from one side, let's see if it's closed. Okay. Meter's still set up for continuity. And we're good. So we know whatever the temperature rating is of that high limit thermostat, this dryer is cold, so that switch is closed. If it got hotter than its set point, it would open. But we just verified that the system should be continuous from here, so we could go to the next step. Okay, so we just came through. High limit safety thermostat is good. So the next thing in line is this heating element. So let's do a continuity check on this element. Okay, if you come back here, here's our heating element. So if we come over here, as you can see, it's red and red. Red and red. Okay, the meter's still set up for continuity, as you can see. So it's the two red conductors on the heating element. Aha. As you can see, we have an open circuit. It's not flowing through that heating element. Just to verify that it's not above 120 ohms, which I know it's not, I'm gonna set this up for resistance. As you can see, when this thing's set up for resistance, any kind of resistance in the circuit is going to show up on that meter. So let's see if we have anything on that heating element. I'm going to bring her back down to those two red wires. Okay, as you see, I'm on. Bring it back up to that meter. And as you can see, it's still OL, out of limits, open loop. So there's definitely an open in that heating element. So okay, so what's our conclusion? We came down, our timer contact's closed, came over for our heat selection. We're on a high heat. We come over here to high heat, L and H. Let's see, L and H. Come over to the heat switch, L1 and C. So L1 and C. Verified those were closed. We continue on to the thermostat. We checked the thermostat down below. Verified that was good. We came up to the safety thermostat, which is right here. We verified that was good. We came over and we just found an open in that heating element. The only thing else that stands between that heating element and L2 is a motor switch, which I'm pretty certain is good, but the only way we can check that is if the motor's running. However, we definitely need to fix this. So we have an open in that heating element. Okay, so to remove this heating element, we're going to have to remove this high limit thermostat. Now throughout this process, before getting your fingers near anything, please be certain that you're disconnected from the power source. I cannot stress that enough. So to remove the high limit thermostat, we're going to want to take and remove this one retaining screw, which is a 1/4 inch nut driver. And then right down there is another retaining screw and the two conductors. Okay, just take and place your high limit thermostat out of the way. Remove that last retaining screw. This side of the heating element just simply moves over, picks up and out. And pull this out. Just like so. And as you can see, we have a pretty obvious open in that heating element. Okay, I was going to buy the heating element local, however I ordered online. It took 2 days to come in, and I tell you what, they were real helpful. Pretty straightforward process, quick shipping. I can't say enough for them. However, to buy it local, they wanted like $72 for the element, and I got it from these guys online, and it was 27 bucks, I believe. Let me double check. And it actually came with a high limit switch as well. Actually, it was only total, it was $24.33. Okay, now with that removed, as you can see, this is, I guess, what you'd call a firebox or something. It's just an enclosure for the heating element. But as you can see, that other thermal, that's another thermal fuse. That's that main thermal fuse that we verified that was good, with the 2 white conductors on it in the very beginning by opening the door and verifying that the drum light came on. That's that thermal fuse. So it's a little hard to get to with everything in place. If you want to take and clean that out, it wouldn't be a bad time to do it. So let's do that and reinstall the heating element. And I'll try to do this one hand man for you. If you come down on an angle, you tilt the back up. And there, like so. Over here, tilt it down, and put it under, and then install your retaining screw. The retaining screw on this model for the heating element is much longer because it also holds that bracket behind. I know you can't see it, but it goes down and retains that thermal fuse in place as well. Okay, so with the new element in place, I just wanted to show you and verify that I'm set up for continuity, and it's a complete circuit. That element is intact. And another time with the leads installed, we're good. Okay, now we're going to take and reinstall the high limit thermostat. Just like so. I remove that felt from there and install that retaining screw. Okay, now that the high limit thermostat's reinstalled, I'm just going to take and install that retaining clip. You want to make sure everything's clear for when this hood comes down, nothing gets pinched. I'm going to clean out the front duct and put the front back on. Okay, the front's reinstalled. Just simply goes down on the front clips, pull it back, make sure your drum's centered, and reinstall your retaining screws. Okay, you want to verify that all the wires are ran nice. Nothing's going to pinch, nothing's going to catch. All the way down. Okay, I think we're almost ready to test it. Yeah, I just slid this out so you can clean up behind there a little bit. But you also want to make sure all your ductwork back here is clean. And, make sure everything's cleaned out, along with your exhaust tube as well, all the way out. And then check it outside of the house as well. Sometimes they have a tendency of clogging up out there depending on what kind of cap you have on it. Okay, before we go too much further, I'm just going to test it. Got the ductwork all hooked back up. Everything's buttoned up except for the back. So you're going to want to keep your fingers clear. So you're going to plug it back in. Verify your control power. We're good. Actually, for this test, since I really can't see the heating element, I'm going to take and pop this front lid up a little bit because there's no safety switches on this upper top. That way we can see if that heating element starts glowing. I don't want it to get too hot. I just want to see if it's working. Then we'll put a load in. I got this top pop, so we should see it glowing back there once we turn it on. So let's test it out. So we know if we put it on a heating cycle, we checked all our circuit, it's good. We checked all our circuit as far as the high heat regular goes. So let's do it. Ooh, there you go. Okay. So we're good. I believe we have it fixed. Come over here to the circuit. Remember, for the high heat, we came all the way across. Once that heat element's good, we come over in the motor switch, so we know that must be working. Motor spins up, closes those contacts, and completes it to L2. Okay, disconnected from the power source, and we're going to put the schematic back where we found it. That way it's there for next time. That was a lifesaver. Just got to plug back into the outlet. Heating duct's all hooked up. Just want to make sure you have no kinks. Make sure nothing came apart when you slid it back. Now I'm going to put it to the test. Put a load of laundry in there, but I believe we have a fix. All right, thanks guys.